Hello everyone, my name is Kan and welcome to my video. This summer, suffering from COVID-19 social distancing, I plan to make some videos of chemistry lessons that I teach in English. I hope that those videos would help you guys to revise your knowledge in chemistry. Firstly, I start with some chemistry lessons in the 11th grade curriculum. Today's lesson is all about dissociation and electrolytes. So let's begin. To start with, just look at those pictures. The pictures describe the mechanism of how sodium chloride, a table salt, and sucrose, or table sugar, dissolve in water. As you can see, those substances dissolve in water in different manners. Sodium chloride is an ionic substance built up from positively charged sodium ions and negatively charged chloride ions. When we put some table salt into water, there are strong interactions between water molecule and the ions in the crystal. Due to those strong interactions, sodium ions and chloride ions are separated individually from the original salt crystal. In contrast, sucrose is a typical covalent compound which cannot separate it into charged ion. Therefore, when we put some table sugar into a glass of water, then stir with a spoon, sucrose molecules can be separated individually from the original crystal and blended with the water molecules. But each molecule does not split into smaller ions. So, the process that sodium chloride crystal is divided into sodium ions and chloride ions when it is dissolved in water is called dissociation and is depicted by this chemical equation. Sodium chloride can dissociate, so we call it an electrolyte. After dissociation, there are only ions in the solution, meaning that sodium chloride have completely dissociated. We call sodium chloride a strong electrolyte. Let's consider another example of dissociation: acetic acid. In this picture, the yellow circles depict acetic acid molecules, while the green ones depict acetate ions. We can clearly see that acetic acid molecules are still present in the solution, meaning that they do not fully dissociate, so we call acetic acid a weak electrolyte. Now we turn to the next part of the lesson. Back to the late 19th century, Arrhenius, a chemist, introduced his theory of acids and bases. According to him, acids are defined as substances that dissociate in water to yield hydrogen ions, or H+, while bases dissociate to yield hydroxide ions, or OH-. Let's say hydrochloric acid is classified as an acid because when dissolved in water, it completely dissociates into hydrogen ion and chloride ion. NaOH, or sodium hydroxide, is classified as a base due to its dissociation into sodium ion and hydroxide ion. However, some substances can act both as an acid and a base. Let's say aluminum hydroxide. Aluminum hydroxide can dissociate to yield hydroxide ion and aluminum ion, or in another way, aluminate ion and hydrogen ion. Substances like this, including zinc hydroxide or sodium bicarbonate, are called amphoteric compounds. We've known that a solution containing ions can conduct electricity. That's why tap water which contain many different ions and other impurities, conduct electricity. But how about pure water? Is it conductive? The answer is yes, but its conductivity is really low. In pure water, there is an equilibrium, as you can see on the screen, with the equilibrium constant is 10 to the power minus 14 at 25 degrees Celsius, indicating that water only dissociates with an insignificant amount, and the product of the concentration of hydrogen ion and the concentration of hydroxide ion is always equal to that constant. When it comes to practice, pH is born. pH is a measure of how acidic or basic a solution is, and is defined through this equation. pH is equal to negative logarithm of hydrogen ion concentration. The common pH scale ranges from 0 to 14, with 7 being neutral. Solutions with pH less than 7 have acidic medium, and those with pH greater than 7 have basic medium or alkaline. In practice, people adjust the pH of the environment to achieve products of their interest. This kind of flower is an example. The color of the flower depends on how acidic or basic the soil is, ranging from deep blue to deep pink color. The last part in this lesson is about reactions between ions in a solution. Let's consider the following elementary reaction. Sodium hydroxide reacts with hydrochloric acid to yield sodium chloride and water. However, the nature of this reaction is not between those molecules, but between the ions existing in the solution. In this solution, there are only ions, namely sodium hydroxide, hydrogen, and chloride ions. The reaction between ions in solutions only occurs when it forms stable products, including precipitation, gas, or weak electrolytes, such as water. Therefore, only hydrogen ion and hydroxide ion react with each other to yield water molecule, which is a weak electrolyte. This equation is called ionic equation. And as you can see, sodium ions and chloride ions do not participate in the reaction. Let's consider a more complicated example. Assuming that we prepare a solution containing these ions. Firstly, hydroxide will react with hydrogen carbonate ion to form carbonate ion and water. This reaction occurs due to the formation of water molecules. Then, calcium ion will react with a newborn carbonate to yield calcium carbonate, which is a precipitation. As a result, after a few seconds, the solution is no longer transparent or is opaque. Finally, I'm showing you some common ionic reactions that you should remember to perform your upcoming test at your best. This list is categorized into 3 parts: precipitation formation, gas formation, and weak electrolyte formation.
Okay, this is the end of this lesson. Thank you for your watching, and if you like this video, why don't you drop a thumbs up and hit the subscribe button. Bye bye and see you in my next video.